In this video, we will look at writing KEQ for heterogeneous reactions and then do some calculations with that. And it's going to follow very much the same process that we've previously looked at for equilibrium constants. All right, let's review the word heterogeneous. Heterogeneous means it's not the same throughout. So I've chosen a picture of a pizza here because you can definitely see that it's not the same throughout. It has pepperonis, it has like sausage, it has mushrooms, it has sauce, it has crust. It's very much different. In the case of a reaction, a heterogeneous reaction is one in which the reactants and or products are all in different states. So perhaps the reactants are gases and the product is a solid, or the reactants are aqueous solutions and there's a precipitate. So that would be a heterogeneous reaction. Anytime there are different states of matter, solid, liquid, gas, or solutions within the reaction. So here's an example. This is zinc and hydrochloric acid. Here's a picture of it over here. The product of this is hydrogen, which you see bubbling off, and then zinc chloride, which stays in the solution. And so the question I've asked you here is, how does the concentration of zinc change as the reaction goes on? So I'm going to pause here for a minute and you think about that, and we'll come back and talk. Okay, the word concentration refers to like the number of moles per liter. Well, a solid doesn't make any sense to talk about concentration of a solid, really, because it can't vary. The amount of moles that are in a chunk of zinc doesn't change. The amount changes, yes, but the concentration doesn't change. So the answer to the question is, how does the concentration of zinc change as the reaction goes on? Is it doesn't. Zinc is a solid, and solids don't change concentrations. Aqueous solutions do, these two aqueous solutions do, and a gas can change its size of container and so therefore change not really concentration, but it's a similar analogous quantity. Okay, so here's another reaction. And so first of all, is it heterogeneous? And we see that it is because there is a solid here. So we react two gases together and produce a solid. By the way, the picture that I've chosen here, this is a farmer who's fertilizing his field with ammonia here. It's called anhydrous ammonia. It has no water with it, and it is put under pressure so it liquefies. So you'll see these things. They always have a green label and oftentimes have a green top. Probably in this case they're taking the top off because it's hooked up to the thing that actually will inject it into the ground. That's ammonia. So this is a heterogeneous reaction. So if we were to write KEQ for this, okay, just to review, KEQ is the products raised to the power in front over the reactants, okay, raised to the power in front of those. So we would put NH4Cl over NH3 times, not plus, times HCl on the bottom. Okay, but here's the thing. This is a solid. And so when we put it in those square brackets, meaning moles per liter, well, there's no change in the moles per liter. So here's what we do for this then. We write the KEQ for the reaction, just like we would normally. But then we go through and we cancel out any ones that have L after them or S after them. Liquids can't change their concentration, neither can solids. Only concentrations of solutions and gases can change. Then you just rewrite the KEQ, leaving those out. And then that will give you the KEQ that you use to do the calculation. All right, so that's all there is to this. You cancel out the L's or S's and you write KEQ normally with those things left out.